Hi everyone, and welcome to Module 10. I'm going to do a brief review of 10.1 as part of this lesson, and then go through parts of 10.2 and a little bit of 10.3 for this week's class. So hopefully if you remember this stuff from our previous class or before, this should be review, but just as a way to kind of refresh everybody and make sure we're on the same page, we're going to talk about what a function is as well as a domain. We kind of skipped part of Module 3, and we're going to come back to it, as Module 10 is a little bit more related to what we did in Module 1 and Module R first. So hopefully this will serve as a good refresher. So the first part of this is what is a relation. And a relation is a mapping from one value to another. So we want to think of our initial values as my inputs. So in this case, that would be 10, 30, and 45. To an output set. So that would be 70, 55, and 95. So we could think of it as a relationship as what I like to call the mapping. That takes us from an X value, aka an input or a domain, into a Y value, also known as an output or a range, okay? Now there are rules to what is defined as a relationship and what is a function, but a relationship is literally just any mapping that takes an X to a Y. Now in math, we have a very specific type of relationship we want to call a function. And that has one real specific characteristic. Any input gets taken to I'm going to use the word unique output. And what that means is a unique output would be only one potential answer. So let's look at this mapping down here with this input and this output. This mapping has 10 being sent nowhere, and that's okay. It doesn't have to go anywhere. It just has to do something. It just can't do one specific thing. So for example, 45 going to 95, that's good. That is sending to one unique output. But here at 30 is being sent to both 55 and 70. So this right here is a problem. This is no longer a function. And the reason for that is because if we think about it, if this is like a set of directions, I either can't go somewhere or I have a very specific map to tell me where I need to go. With this one, it's telling me to be at two different places at the same time. So if I said, let's go to the movies and watch and get dinner, I want them to be at two different locations, but at the same time. That's a problem. There's not two of me to go to do the same thing at the same exact time. So this is why we can't have a function, because if I have a singular input, it has to go to only one option. Now, with that being said, it's okay for an input to go to a lot of the same outputs. So, for example, let's pretend that this line is no longer here. Let's ignore that. But let's say 10 now goes to 55. Is that okay? And the answer is yes, because it's two different starting points that just end up at the same location. So you just can't have one input go to multiple different outputs. Every other scenario is okay. So here is an example of a pure function where each input goes to a unique output. There is no double input directions. And even if 10 went to 55 and 30 went to 55 but not 70, then that would work. Now, there is a way to do this on a graph that's a little bit more interesting. So we have what's called the vertical line test. The vertical line test allows us to determine if something is a function or not. To do that, all you have to do is draw vertical lines. Now, it's impossible to draw all of them, so just take a few. But what we're looking for is if my vertical line crosses my graph more than one time. No matter how I draw this, even if you think I've done it twice, it's just my shoddy drawing here. This passes because there is no line that touches more than once. So that's a quick way to test if a graph is a function. Now, when we talk about domain and range, we want to think as domain as the input. And this is an output, my range. So domain is considered all the potential values that might make sense in a problem. So let's look at this. Lenny has an extensive CD collection that he's been selling. He knows that he has this data. If he sells 2 CDs, he makes $8. If he sells 4 CDs, he makes $16, so on and so forth, 5 and 20. What would be the domain of this set? So the domain would just be all the CDs sold. So 2, 4, 5, 10, 12. Does that mean it's the only potential domain that to exist in this context? No, it's just the domain that's been given to us. And the range would be all the money that he's made. 8, 16, 20, 40, and 48. We know that if he kept selling CDs at different values, he would make more money. But just based on the information presented to us, we might assume he can only sell CDs in these types of groupings for this amount of money. But that is what we would register as the domain and range. Then it says write the domain and range as a set of points. So since they're all just kind of listed in a row, so this would be 2, 8, 4, 16, 5, 20, 10, 40, 12, 48. And then is this a function? Well, the answer is yes. Since each of the domains go to a unique range, this is a function. Now, as mentioned previously, we have that vertical line test. And so here's an example in which my graph has 2 intersections. So this would fail the vertical line test. Now, the reason we want to talk about this in terms of domain and range is because domain is all my x coordinates. And range would be all the y coordinates. So one thing that might be interesting for you to see is that you see how this line crossed the 1? Essentially what that means is my domain is 1. My range has 2 results, 3 and -3. So imagine back to that previous question about Lenny, and let's say this graph represented how he sold things. This is like me saying he sold 1 CD and he made a profit of $3 and -$3 at the same time. So you can see how that doesn't really make any sense as a descriptor for something involving a domain and range. He both made money and simultaneously lost money while selling something, and it's the same item that he sold. It just doesn't make sense. So that's why we use this function test to understand where functions can go. So a little bit more on domain and range. As we talked about domain as coordinates, it's pretty straightforward. In terms of a chart, graphs get a little bit trickier. So the way that you want to imagine domain is it is all x values on the leftmost part of the graph to the rightmost part. So if you look at this graph here, it's this red line. If I look at the leftmost portion of my graph, it starts at this coordinate. I want to think about taking this coordinate and basically trying to place it where it would fit on the x-axis, so -6. And then when I go to the rightmost part of my graph, you can see it's all the way up here. If I was to squish that onto the x-axis, that would be at 3. And for any point in between those dots, it corresponds to something on my x-axis. There's no gaps going left to right. So it's really easy to see that the domain of this graph can be anything between -6 and 3. And the way that we write that is with a bracket -6, because it's a closed circle, to a bracket 3. Range, on the other hand, is a similar concept, but the only difference is it's all y values from the bottom to the top of the graph. Now with that, if I look down here, from the lowest coordinate, you can see it starts at -5. And from the highest coordinate, it starts at 4. And so if I, again, think about how would this line connect to the y-axis, I've got no gaps going from the bottom to the top of the function. So my range would be this portion of the y-axis. So my range would be from -5 to 4. Whenever we write domain and range, we want to look for the lowest numbers to the highest numbers. So it always goes lowest to highest. And then if it's a closed circle, we use a bracket, in which case this one was. And if it's ever an open circle, we use a parenthesis. Now you may be wondering, if I go back and I erase all this wonderful stuff on my graph, you may be wondering, okay, how do I establish that these are closed circles? Truth be told, for this, you have to be told it's an open circle. You can't just say it's not an open circle. If it does not tell you it's an open circle, we assume it's a closed circle. So that's why I use brackets for both. And so here's just another sort of visualization on how I get those sort of graph pieces. So let's talk about domain and range for a function like this. Now, when we do domain, each graph will have its own unique domain. So it's understanding how we can interpret it. So the leftmost part of the graph is this part of my circle. And if I think about squishing that onto the x-axis, that would start at -3, and I can go above or I can go below, but no matter what, I always end up here as the rightmost part of the graph. So we would say that the domain of this graph is -3 to 3. For range, we start at the bottom. Now that is the lowest it goes. And again, I can follow my circle in either direction, so I can circle it up to the right or circle it up to the left, but the highest I go is 5. So my range would be -1 to +5, and that's it. That's all we really have to establish here. So here's a ellipse or an oval, and so take a second to think about first what would be the domain and what would be the range. But as we look at the graph, it hopefully should make sense. My domain would be -3 to 1, because the leftmost part of the graph starts at about -3. The rightmost part of the graph starts about 1. My range, the lowest part would be -4, and the highest part would be 4. So that's it for domain and range on graphs like that. As we study more functions, they'll have their own special ones, but there are some things that we have to know. So here's some more tricky examples. Now this is a piecewise function, and we're not trying to interpret these as two different pieces. We're trying to interpret it as a whole. So this graph is going to keep going to the to the left forever. And so this one's going to go to the right forever. And so let's think about what the domain would be here. Well, the graph starts to the left forever. And so the number that represents the left would be -infinity. Now, we never put a bracket on infinity, so we're not going to do anything. But as I read the graph left to right, I don't have any issues until I hit right here. This is an open circle. So when I think about where it lines up on the x-axis with 2, I shouldn't include it. The only thing is, I actually have one that matches it. So 2 is actually okay to include. and then I can keep reading the graph. And again, there's no other holes in the graph. There's no other breaks. So the graph goes from negative infinity. And even though there's this little blip here at 2, since I have both the open and closed circle, it's okay. So my domain would be negative to positive infinity. Now for range, this one actually is going to have a problem. So I can start, both of my arrows at the end here are going down forever. So that means the lowest value this graph can get to is negative infinity. But as I work my way up on both the left and the right hand side, the highest I can get to with no issues is this number, positive 3. But since there's an open circle at that high point, I can't actually say 3 is attainable, so we have to use a parenthesis. Now my next graph, this is going to be a little bit more straightforward since there's no real gaps, it's just knowing where to start and stop. The leftmost part of the graph is 4, negative 4. The highest x value it can take on is 2, but not including it. So my domain would be negative 4 with a bracket there to 2 with a parenthesis. My range would be negative 3 to positive 3. And again, negative 3 would be bracketed, positive 3 would be a parenthesis. All right, and this is the last topic I want to talk about in this module, and we've done this before, talking about x-intercepts and y-intercepts. It's just important to reiterate that x-intercepts have the form number 0, and y-intercepts have the form 0 number. So when I look at my x-intercept for this graph, it crosses right here at negative 1, 0, but my y-intercept crosses at 0, 1. So that would be it for intercepts. So feel free to go through and work through some of the problems in 10.1. The one topic we didn't get to, and I don't want to do just yet, is difference quotient. So those are problems that we will come back to soon. Thanks, and I'll see you in the next part.